Hello and welcome to Period Algebra. We are on Unit 1, Section 1. Our very first section is on comparing and ordering integers. Now, for some of you, this might be a review. For some of you, you might have seen it before, but maybe forgot a little about it. For some of you, it might be brand new. Either way, feel free to use this video how you need to. If you can go through it quickly, that's great. If you need to stop it, pause it every now and then. If you need to rewind, if you need to rewatch, that's all up to you. Just make sure you complete the Unit 1 Section 1 notes and show them to your teacher before you start the Unit 1 Section 1 check-in. So just to review, integers include negative numbers like -4. They include 0, and they also include positive numbers like +15. Those are all integers. Integers do not include decimals though, so for instance 6.2 would not be an integer. So in the first part of this section, we're going to work on graphing integers. So the directions say graph the integers on a number line and write the numbers in order from least to greatest. So for number 1, our integers are -14, -11, -13, -9, -20, and -7. So if you look, there's a line provided for you. I've gone ahead and added on tick marks every 5 numbers. If you want to go ahead and draw something like that as well, feel free. And then we're just going to go through and we're going to plot each of these integers on that number line. So our first integer is -14, which I'm going to put just to the right of -15, because remember, as we go left from 0 on a number line, although the digits get bigger, the numbers are actually smaller. -11 is going to be just to the left of -10. -13 is going to be pretty close to -14, but to the right of it. -9 is going to be just to the right of -10. -20 is going to be right on -20. And -7 is going to be just to the left of -5. So I've graphed those integers on the number line. The next step is to then write the numbers in order from least to greatest. So when I look at my number line, I can just go from left to right. So that means that my least integer is going to be -20. My next one's going to be -14, -13, -11, -9, and -7. So now I've got those in order from least to greatest. If you look at the next one, we've got -30, 20, 10, -15, -5, and +35. So our numbers are a little more varied. So if you look, I actually had to extend our line a little bit to get more numbers on, and I just went by tens this time. So I'm going to go ahead and plot these numbers on there. So the first one is -30, which is going to go directly on -30. Then I have 20, which is going to go directly on 20. 10, which will be directly on 10. -15, which is going to be halfway between -10 and -20. -5, which is going to be halfway between 0 and -10. And then 35, which is going to be between 30 and 40. So I'll just plot all those on my number line. I'll graph them on my number line. And then to write them in order from least to greatest, I can just go left to right. So that means I'll have -30, -15, -5, 10, 20, and 35. And now those are in order from least to greatest. The next thing we're going to talk about are absolute values and opposites. So the definition of an absolute value is the distance of a number from 0 on the number line. So for instance, let's go ahead and say this is 0 on the number line. And I'm going to put -11 over here. I'm going to put +6 over here. The absolute value of -11, which is what these bars mean that are outside it, would be 11. It's the distance from 0. So the absolute value of -11 is 11, because we're just talking about the distance. The absolute value of 6 from 0, or the distance from 0 would be 6. So the absolute value of 6 is 6. So if you noticed, whether an integer is positive or negative, when you take the absolute value of it, that absolute value is positive. The next thing we're going to talk about are opposites. So opposites have the same absolute value or the same distance from 0, but they have different signs. So again, let's put 0 on our number line, and let's say we have 10 and then -10. So negative 10 and 10 are opposites, because if you think about it, they both have an absolute value of 10, but one's negative and one's positive, so they have the different signs. So let's look at stating an absolute value of some integers. So again, remember the absolute value is its distance from 0. So whether it's negative or positive to begin with, when you take the absolute value, it'll be positive. So the absolute value of 1 will just be 1, because it's 1 away from 0. The absolute value of negative 9 would be positive 9, because we're 9, the distance of 9 away from 0. The absolute value of 15 is 15. And the absolute value of negative 12 is 12. So just a reminder, when you're doing absolute value, regardless if it's negative or positive to begin with, the absolute value is going to be positive. Okay. On the next part, we're going to state the opposite. So whatever sign it has to begin with, if it's positive to begin with, when we do the opposite, it's going to be the same number, just negative. If it's a negative to start with, when we do the opposite, it's going to be positive. So the opposite of 14 would be negative 14. The opposite of negative 33 would be positive 33. The opposite of negative 24 would be positive 24. And the opposite of 81 would be negative 81. On the back side of your notes at the top, we're going to complete the statement by using the less than sign or the greater. So this first one means less than when you read it from left to right. The second one means greater than when you read it from left to right. The way I like to think about it is that if that's like a Pac-Man mouth, you're always going to eat the bigger number. Right? So the first one we have is we have negative 11 and negative 9. You could either just, if you can recognize which one's greater, you can do it that way. If you wanted to, you could also put it on a number line. So if we put it on a number line, we could say negative 11 would be here, negative 9 would be there. And we remember from the first page of the notes, the numbers to the left are lower than the numbers to the right. So we would say that negative 9 is greater. So we're going to have our sign open towards the negative 9. So if we're going to read this from left to right, we would say negative 11 is less than negative 9. For our second one, we have 1 and we have negative 5. Again, if you can just recognize from looking at it, go for it. If you want to, you could use a number line. Negative 5 would be to the left of 1. Okay, so we know that negative 5 would be less than 1. Or we could say that we're going to open towards the 1. And if we read this from left to right, we would say 1 is greater than negative 5. Now for this one, you wouldn't really need to use a number line because we know that a positive number is always going to be greater than a negative number, regardless of the digit. This digit 5 might be bigger than the digit 1, but since 1's positive and 5's negative, the 1's always going to be greater. All right, I'm going to leave number 3 for you guys to try. Just be careful because that absolute value symbol is there. All right, moving on to the next part, we're going to evaluate expressions. Okay, one thing that I want to let you guys know, and we'll remind you of this throughout pre-algebra, is that we evaluate expressions. An expression does not have an equal sign. An equation does have an equal sign. So that's what why these would be expressions. So we have the absolute value of negative 32 plus the absolute value of negative 6. So the absolute value of negative 32 would be 32 plus the absolute value of 6 would be 6. So 32 plus 6 is 38. So we evaluated that expression and got 38. All right. For number 2, we have a negative out in front, and then we have the absolute value of negative 7 plus the absolute value of 12. So the absolute value of negative 7 would be 7. But we have that negative that's out in front, and the absolute value of 12 is 12. So we have 12, we could rewrite this as 12 minus 7, and we would wind up with 5. For the last one, when we have these absolute value bars, they almost serve like parentheses if you've done PEMDAS in the past, which means we need to work that out first. So inside the absolute value, we need to do 18 minus 4, which would be 14, minus 9 minus 4, which is 5. The absolute value of 14 is 14. The absolute value of 5 is 5. 14 minus 5 is 9. For the next part, we are going to evaluate these expressions when x equals -7. And all that means is that whenever we see an x, we're going to plug in -7. So for the first one, we have the absolute value of -x. So we'll have the absolute value of -7. Because we have the negative that's already there in front of the x, and then x actually is -7. So before we do anything else, we have to say that a -7 is the same thing as a +7. If we do a negative number times a negative number, we get a positive number. The absolute value of 7 is then just 7. I'm going to go ahead and let you guys try number 2. So you go ahead and work that out. You're going to evaluate with -7 as x for number 2. So if you need to, pause this video, work that one out, and then move on to the next one. So for number 3, we have 6, and then we need to replace x with -7. So we have 6 times the absolute value of -7. The absolute value of -7 is 7. So now we're just multiplying 6 times 7, and we get 42. Again, if you have any questions, just pause it, go back and watch if you need to. If you're in class, you can go ahead and ask your teacher. And then for the last part, we are going to continue to evaluate expressions, but we've got more variables involved. We're given integers for each variable, so we'll still just be plugging in where we see those variables. So for the first one, we have 2y minus the absolute value of x. So I'm going to rewrite my 2. I'm going to replace the y with 4. And I have minus the absolute value of x. They tell me that x is -3, so I'm going to plug in -3. 2 times 4 is 8, minus the absolute value of -3 is 3. So then I have 8 minus 3, and I get 5. Right. I'm going to leave number 2 for you guys to try. Just do your best. If you have trouble, you can ask your teacher during class. All right, that's all for the Unit 1, Section 1 video. Please make sure these notes are completely filled out and you show them to your teacher before you move on to the check-in.